In this next series of videos, we're going to be talking about gas laws, including Boyle's, Charles, Gay-Lussac, Dalton's partial pressure, and ideal gas law. So it's important to note that for these gas laws, we're going to be using the temperature scale Kelvin, which is the absolute temperature scale. And Kelvin is equal to Celsius plus 273. Now, all of the equations for these gas laws, along with the temperature conversion, are included in your reference table. But before we begin learning to quantify these things, we're going to just look at them conceptually. So we have to sort of recall the nature of gases, and we're going to use a simulation to look at what's happening in terms of the pressure, volume, and temperature of a gas. So remember that gases are made of particles that are high energy and they're spread out from one another. They're undergoing random elastic collisions, and the force and the frequency with which those molecules strike the container that they are in determines the gas pressure. So let's just go ahead and look at a simulation that helps us to sort of visualize these things. So I have a container of a specific volume here. I have a thermometer to measure temperature, and I have a pressure gauge. So right now the pressure is 0 and the temperature is 0 because there's no gas molecules in here. It's a vacuum. So let's go ahead and just add some gas to it. And as I do, we can see that now these particles are randomly bouncing around. They are striking the side of the container, so I have some pressure, but also I have some temperature. Remember that temperature is the average kinetic energy of the molecules. So if I were to increase the kinetic energy or the motion of the particles, the temperature would go up. But that would also cause these particles to strike the container more frequently and with more force, and therefore it would make the pressure also go up. So let's just add a little bit more gas to the container, and as we do, we see the pressure increases because the gas is moving around and striking. There's more particles to be striking the container. Now if I were to add some heat, it would make the particles move faster. And so you can see the temperature goes up because the kinetic energy is increasing, but also that causes the pressure to increase because the particles are hitting the side of the container. Now let's see what happens if I change the volume. If I make the volume of the box smaller, now the particles are cramped into a smaller space, and therefore they're hitting the sides more frequently, they have more energy, and they're heating up. So we can see that the volume of the container, the temperature of the gas, and the pressure are all very closely intertwined. So that's what the gas laws are going to help us to quantify. So in the next video, we'll begin learning about the gas laws, and we'll look at the math of how to relate pressure, volume, and temperature.